Hi, welcome to section 8.4, Intro to Set Operation. Before we get into any examples for set operation, we're going to cover the type of sets. So let's take a look at the first set. The first set is called the universal set, represented by set U. What I mean by represented by set U is it will always be denoted as set U. So any given problems for set operation, you have a set U or the letter U. This set will always be given and contains given elements. So in every problem that you come across, you always have a set U. And in set U will be elements, and these elements can either be numbers or letters. So if in a problem your set U or universal set has elements that are numbers, that means that your problem will most likely have elements that are numbers. If your set U has elements that are letters, then most likely your problem will have elements that are also letters. Let's take a look at the next set, the union set. Union set, symbol represented by this, which is usually a large U. So it's a symbol for union. So for a union set, you are to combine two sets together as one set. So I repeat, combine two sets together as one set. And if there are any repeating elements between the two sets, then it will be written once. So I repeat, if there are any repeating elements between the two sets in the question, then it will be written once. All right, let's take a look at the next one. The next one is the intersection set. Intersection set, which is represented by this, and it looks like a N symbol, but we're just going to call it the intersection set or the intersection symbol. So for intersection, it's a set of common elements only from both assigned sets. So it basically means that it's a set or intersection set that has common elements, meaning that elements that are in common from two sets that it asks. So when you have given two sets, and if it asks for the intersection, that means that you're looking for common elements, elements that are in common. So I repeat, elements that are in common between the two sets it asks about. All right, so let's take a look at the next one. Complement. Complement, so which is represented by this apostrophe right here in red. If you look closely, complement has a symbol that represented by this right here. We usually call it the apostrophe right here in red. So I gave three examples. So here we have the A complement set. I said A complement because it has that red apostrophe at the top right. And then here I have B complement, and then I have C complement. So these are three examples where it has that red apostrophe at the top right of each letter. So a complement is a set that contains element from the universal set. So again, universal set is the first set we talked about, but does not exist in the assigned set. So what I mean by does not exist in the assigned set, so if I'm looking for a complement, I'm going to look for elements from the universal set, but I'm not going to look for the one that already exists in set A. So to cover that and repeat that, set A and set A complement are two different sets, which I will cover that in the examples that you will see later on. But to repeat, set A, which is not this that I'm circling, and set A complement, which now I'm circling right here, there are two different sets. So I'm going to cover an example and go more in depth for complement set. But again, complement is a set that contains element from the universal set. So we will be using a universal set for complement, but we're not going to include elements that does not exist in the assigned set. So To clarify again, we're not going to use elements that exist in the assigned set.